In quick tip number 4, we'll describe how to solve a right triangle when we're given two different sides of the triangle. Now, first of all, when we're solving a triangle, we mean that we're determining all the sides and all of the angles in the triangle. In this case, we're given two sides. We'd like to determine the remaining side. We're given one angle. We'd like to determine the measures of the remaining two angles. Well, since this is a right triangle, we can apply the Pythagorean theorem. This missing side is the hypotenuse, so let's call that C. The sum of the squares of the lengths of the legs is 25, so that taking square roots, we can see that the length of the missing side is 5. And now we're ready to compute some angles. Let's start with this one. We'll call this angle theta. And we could do any of the sine, cosine, or tangent. Let's work with the tangent here. The tangent of theta is equal to the length of the opposite side over the length of the adjacent, so that's 4/3. And from this we know that theta is equal to the inverse tangent of 4/3. This we can estimate on the calculator easily. Don't forget, check to make sure your calculator is in degree mode. Right there. Then we want the inverse tangent of 4/3. And that's about 53.13 degrees. So that takes care of this. Now, for this other angle, let's give that a name. I'll call it alpha. For this angle alpha, I could do the same thing. I could say that, the tangent of alpha is 3/4. But I could also do this by subtraction. I know the angle theta, and I know that this is a right angle, or 90 degrees. So the angle alpha can be obtained by subtracting from 180. The sum of the measures of all the angles in a triangle is always 180. Angle we just solved for is 53.13. And of course, there's a right angle in here as well. So what remains must be the measure of the angle alpha. 36.87 degrees is this angle here, and now we have all three sides and all three angles. The next one is very similar, except in this case we have a leg rather than the hypotenuse is the length that's unknown. So a squared plus 11 squared is equal to 13 squared. Squaring all those out, 169, that's 121. So a squared is 169 minus 121, and the difference is 48. That's the square of a. So a, we take the square root of both sides, must be the square root of 48. Now, if you want to leave this in an exact form, it would be best to observe that this is 3 times 16. The square root of 16 is 4. So this is 4√3. That's the reduced exact form. Or we might want a decimal approximation. Now you could get it from this form or this form, it doesn't matter. The calculator will give the same result. So let's take square root of 48, and that gives us 6.9282. Okay, we have the missing side. Now we'd like to compute these two angles, and I'll just label this with theta and alpha as I did above, just to remain consistent. Last time I started with theta, so this time let's do alpha. For alpha, how about if we do the sine this time? The sine of alpha is its opposite, length of its opposite, divided by the length of the hypotenuse, so that alpha is the inverse sine of 11/13. And we can get that number with our calculator. $57.80 if we round off. And the units are degrees. To find the angle theta, we would do the same as we did up here. The sum of the measures of the angles of a triangle is always 180. We have a 90-degree angle, which we know because we have a right triangle. We've used up another 57.8 degrees in the angle alpha. So when we subtract, the remaining is 32.2 degrees. And that must be the measure of the angle theta. Well, that's it. We've solved for all three sides and all three angles in both triangles.